Why compile Python code? Why would you compile a Python script? You can run them directly from the Py file and it works fine, so is there a performance advantage or something? I also notice that some files in my application get compiled into Pyke while others do not. Why is this?
It's compiled to bytecode, which can be used much faster. The reason some files aren't compiled is that the main script, which you invoke with Python main.py, is recompiled every time you run the script. All imported scripts will be compiled and stored on the disk. Important addition by bin blank. It's worth noting that while running a compiled script has a faster startup time, as it doesn't need to be compiled, it doesn't run any faster.
The Pyke file is Python that has already been compiled to bytecode. Python automatically runs a Pyke file if it finds one with the same name as a Py file you invoke. An introduction to Python says this about compiled Python files. A program doesn't run any faster when it is read from a .pyke or .py file than when it is read from a .py file. The only thing that's faster about .pyke or .py files is the speed with which they are loaded. The advantage of running a Pyke file is that Python doesn't have to incur the overhead of compiling it before running it. Since Python would compile to bytecode before running a Py file anyway, there shouldn't be any performance improvement aside from that. How much improvement can you get from using compiled Pyke files? That depends on what the script does. For a very brief script that simply prints "Hello World," compiling could constitute a large percentage of the total startup and run time. But the cost of compiling a script relative to the total run time diminishes for longer running scripts. The script you name on the command line is never saved to a Pyke file. Only modules loaded by that main script are saved in that way.
Pluses. First, mild, defeatable obfuscation. Second, if compilation results in a significantly smaller file, you will get faster load times. Nice for the web. Third, Python can skip the compilation step. Faster at intel load. Nice for the CPU and the web. Fourth, the more you comment, the smaller the .pyke or .py file will be in comparison to the source.py file. Fifth, an end user with only a .pyke or .py file in hand is much less likely to present you with a bug they caused by an unreverted change they forgot to tell you about. Sixth, if you're aiming at an embedded system, obtaining a smaller size file to embed may represent a significant plus, and the architecture is stable, so drawback 1, detailed below, does not come into play. Top-level compilation. It is useful to know that you can compile a top-level Python source file into a .pyke file this way. This removes comments. It leaves docstrings intact. If you'd like to get rid of the docstrings as well, you might want to seriously think about why you're doing that, then compile this way instead. And you'll get a .py file instead of a .pyke file, equally distributable in terms of the code's essential functionality, but smaller by the size of the stripped out docstrings, and less easily understood for subsequent employment if it had decent docstrings in the first place. But see drawback 3, below. Note that Python uses a .py file's date, if it is present, to decide whether it should execute the .py file as opposed to the .pyke or .py file, so edit your Py file, and the .pyke or .py is obsolete and whatever benefits you gained are lost. you need to recompile it in order to get the .pyc or .po benefits back again, such as they may be. Drawbacks. First, there's a magic cookie in .pyc and .po files that indicates the system architecture that the Python file was compiled in. If you distribute one of these files into an environment of a different type, it will break. If you distribute the .pyc or .po without the associated .py to recompile or touch so it supersedes the .pyc or .po, the end user can't fix it, either. Second, if docstrings are skipped with the use of the U command line option as described above, no one will be able to get at that information, which can make use of the code more difficult, or impossible. Third, Python's U option also implements some optimizations as per the O command line option. This may result in changes in operation. Known optimizations are: sys.flags.optimize equals 1, assert statements are skipped, _debug_ equals false. Fourth, if you had intentionally made your Python script executable with something on the order of #!/user/bin/python on the first line, this is stripped out in .pyc and .po files and that functionality is lost. Fifth, with option O, as well as U, assert statements are not compiled in, eliminating a source of runtime validation. You can compensate for this by using try except, but this requires abandoning the assert statement for use in anything that will be compiled. Sixth, somewhat obvious, but if you compile your code, not only can its use be impacted, but the potential for others to learn from your work is reduced, often severely.
Something not touched upon is source-to-source compiling. For example, Nuka translates Python code to C++ and compiles it to binary code which directly runs on the CPU, instead of Python bytecode which runs on the slower virtual machine. This can lead to significant speedups, or it would let you work with Python while your environment depends on C++ code.